Delicious. Hello everyone, and welcome back to Philip's Couch Bed. You may be asking, why am I in bed eating soup? Well, the answer to that is, recently I got sick. It's a very long story, involves trees, the weather, and yeah, mostly just trees and the weather. Oh, also pizza and a ferret, but it's a long story anyway. Actually, I'm not sick anymore. I got better about a week ago. I just thought this would make a neat little aesthetic for this video. And yes, before you ask, I am going to be doing this for the whole time, so get used to it. So, I have recently been asked several times to perhaps provide less insane explanation of the fuzzy KNN program, which if you missed my last video, well, if you missed my last video, you probably don't actually, it's not really useful at all if you actually want to learn about the fuzzy KNN program, because, you know, if you just watch that video, you'll be mistaken for thinking that was just, oh, Philip's finally snapped. He's about to go on a murderous killing spree, you know, and this whole thing about the stabbing of the cats is just made up. Well, the part about stabbing cats, that was made up, alright? That was made up. But, oh crap, I just spilled a little drop. But that part was made up. The part that wasn't made up was that there is, in fact, I think, a relatively new AI / program / equation thing called the fuzzy KNN, that is meant to detect pulsars. Or rather, the telescopes would detect pulsars, and then fuzzy KNN would take that data, then interpret it. Because one of the problems with detecting pulsars, which, if you don't know, a pulsar is essentially a neutron star, which, if you don't know what a neutron star is, then it's kind of like a mini black hole. Like a black hole forms when a really large star collapses in on itself. And, you know, there's an infinitesimally, like, ridiculously small point, infinitely small point, that is created because of that, essentially the massive mass of that star is being compressed so much, and that's why black holes have such a, and that points to the singularity, and that's why black holes have such great, awesome power, you know. Neutron stars are what happens when slightly smaller stars collapse. They're not quite as they're not quite as weird as black holes when it comes to like distorting time and space and stuff, but they come with their own sort of quirks, you know, like how they're formed is the core of a star collapses, and then all the stuff inside of the atoms are compressed so much that they fuse together, and with all the electrons and the protons and stuff fusing together, it just creates this soup of neutrons, which are the neutral particle, which is why they are called neutron stars. Makes sense. So a particular breed of neutron star is called the pulsar. It doesn't actually pulse, is the weird thing, because again, the scientists suck at naming things. Fight me. Anyway, the pulsars actually are neutron stars that have jets of electromagnetic radiation bursting from both of their poles, and they rotate very quickly, which makes it seem like they're pulsing, because obviously if you take a light and you spin it and someone is looking at that light from like a decently long distance away, it's going to look like it's flashing, even though it's not. And so scientists, they obviously want to know about these pulsars, but a problem that comes with detecting them is that it's hard to differentiate between a pulsar and just random electromagnetic interference and stuff. So usually, back in the olden days, you would have to, sort through everything by hand, but now you have computer programs that do that job. But they're still not very good at it, is the problem. So, somewhat recently, this new one called Fuzzy KNN was created. And this one is apparently, from the study that I'm referring to, has been shown to be quite a bit better. And now what this study says is essentially the reason it's better, from my understanding, because obviously I am not an expert on this, the reason that it is better is because usually, well, first of all, it's simpler, and it draws on a greater database, which, sort of reduces the room for error because it has more stuff to compare it to. And because of the simplicity, there's less things that can go wrong. But that's relatively understandable. The interesting part is that when usually these programs would just look at each candidate for whether it's a pulsar or not individually, and this lacked a lot of nuance, and it was also pretty slow. So what this new Fuzzy KNN program does is that it ranks them. It ranks the possible candidates from, depending on how likely they are to be a pulsar, and I think the soup is making me sick. You betrayed me, soup. You were supposed to do the opposite. Still delicious, though. Mwah. But anyway, so where was I? So it ranks the things, the candidate things based on how likely they are to be a pulsar, and also based on the amount of other candidates that are near them. And this allows for a lot more nuance. It allows for a lot more efficiency. And unfortunately, or fortunately, depending on how you look at it, I guess, no cats require stabbing. So yes, that was my slightly less insane explanation of the Fuzzy KNN program. Hope you all enjoyed. I know this was sort of a less ranty, less insane, less haha jokey video, but this was just meant to sort of, explain the actual science behind, or emerging science, I guess, because it is a somewhat new study. Well, anyway, like the video, subscribe, whatever, or don't, I don't really care. I'll see you in the next video where I talk about something. Probably pretentious, definitely, definitely pretentious. It will definitely be quite pretentious, and most likely I will return to my ranting format, so look forward to that. That's pretty much it. That's it. Why are you still here?